Alright, so to get started, you're going to need maybe a 1 liter bottle. This is my favorite, Diet Mountain Dew. So I got lots of them around. And you want to cut it off right above the label. Great. So now you've got the lid on there. We need to drill a hole in the lid. And I like to use a 3/16 inch, which almost perfectly fits a 5mm LED. So just try to find the center. It's not super important to be perfectly in the center, but you want it to be close. You don't even have to use a drill. I'm just going to do this by hand. There we go. It's coming right along. Great. Just give it a little bit of cleanup in there. Perfect. Okay. So in addition to that, you need some tin foil, which is probably optional. You need an Arduino. I use an Uno, which is a nice one, pretty cheap. I don't know, 10-15 bucks or something on eBay. A 220 ohm resistor, and some kind of a LED. This one's a white LED that I use. And then some wire just to make it a little more convenient. So that's it. Take the LED and then solder onto the long leg of the LED. You want to solder it onto this resistor. So I just kind of twist them together, then I'll go over to the solder station and solder them. Do that, and then take some of this wire, cut a nice little piece off here. Sure, that's great. Probably use better tools for this. Strip it back a little bit. And then the red end goes on here, just like this. And the black end goes on the short leg. If you don't have red and black, it doesn't really matter. You just need to make sure the polarity is right or it won't work. You have to switch your wires around. So, there we go. So I'm going to take that off to the soldering station and I'll bring it right back in a minute. I'm also going to just tin these ends so I can stuff them into the Arduino ports without having, worrying about the pins. Should be good. Okay, so I'm back. Got this all soldered up and I taped it so it won't short out. And I just tinned the ends of this piece of wire so I can put them right there. I'm going to go ahead and hook those up to the Arduino. The red one goes into the 5-volt port, which is right here. Should just slide on in. Great. And the black one goes, I think I've got it programmed to pin 8. Just like that. That's all you got to do for the electronics. This will literally just run off your computer. Or a portable battery bank. So I can plug this in here and you can see the LED start to work. This is just my anchor bank. I don't know if you'll be able to see anything in the camera, but it's definitely glowing, and it's running the program I already put on there, which I'll post the code separately. Super simple program, but it's flashing at 300 Hertz square wave. That's how we'll inject that right into the lens of the camera and see if we can't identify the rolling shutter. Okay, so now back to this piece. I'll just put that over there for now. I'm going to put some tin foil inside it, just to give it a little bit of reflectivity inside. Just tape around the edge here so it doesn't go anywhere. Okay, so that's it. So we have our cap off with the hole in it. We got our LED all soldered up here with the Arduino on it. That's great. I think we'll just poke a little hole in the bottom here with our scissors to let the light shine through. stuff the LED into the light, to the cap. Perfect fit with that 3/16 drill bit. I'm going to spin this on. So you can see the LED in there. If I turn it on, you should see it shining a little bit. Great. Kind of just try to make this all reflective inside. Not super critical, but you can see a little bit of a white spot. Doesn't matter. We're going to use our, as long as it's close. So after this, I want to use just a piece of a plastic bag that I have. This is some, I don't know, maybe a memory card came in it. But I want to give a little bit of diffusion to the LED so it's not just a white circle. So we'll just take this and cut it into a piece about maybe that big. That's great. And then we're going to tape it inside in front of the LED. Just to give a little diffusion way down in there. Stuff it in about, I don't know, about there. Okay, that should be good. So we got a little bit of diffusion over there. A little bit. We'll add a little bit more when we actually put it on the camera lens, which I'll do right now. Go grab one. So here's my Pocket Cinema 4K. I guess we can test this one. I've got this little extra diffusion I can put on over here. This slides right over here. There we go. Set it up on our tape for right now. We can turn the camera on. Oh, and look at that. I've already got it going. I don't know if you'll be able to see this very well or not. But you can kind of see some lines going up and down the screen, I hope. I'm going to turn our shutter angle down until we get, set our frame rate to maybe 24. Great. Set our shutter angle down a bit more. There we go. So you can just kind of mess around with the shutter angle until you get what looks like some pretty nice clean lines. Like that, 22.5 degree with the setup. Then we can maybe turn the ISO down a little bit. Just want to get good contrast so you can count the lines. That's all we're really trying to do here. Record a quick clip just for a second. Hit play. We can come back here. We can count the lines on the screen. So we have 1, 2, 3, 4, 5, 6, 9, about 9.5 lines. So 9.5 lines with the code that we have, it's 300 hertz. 9.5 lines works out to, let's see, it'll be about, take 9.5, divide by 2. So that gives us 4.25. And then we're running at 300 hertz, so we'll take 1 over 300. That's 3.3 milliseconds per set of lines, per pair of lines, because we have an on cycle and an off cycle. So the bright line and the dark line go together. That's why we divided by 2 up here. So we'll take 3.3 milliseconds times 4.25. That's going to be like right at 16 milliseconds. So we just measured our rolling shutter just like that, 16 milliseconds, piece of cake, and that's about right. So we can verify that. Let's maybe go look at a different mode. Let's switch it over to, I don't know, let's go to 1080p. And we'll use a smaller, we'll downscale or undersample the sensor. Oh, that's very different, right? So I don't know if you can see this, but let's turn our ISO down a bit more. Yeah, see the lines got a lot bigger. Bigger lines mean it's a faster scan rate. The perfect condition you would want, you know, one giant line that would be a global shutter. But it's just a little bit off, so we'll play with our shutter angle until we find something that, you know, slows it down a little bit. It's not too bad. It's gotten brighter. So we'll hit record, stop record, and hit play, and we'll go back and we should be able to count these lines. I got 1, 2, 3, 4, 5, maybe 5 1/4 lines. So 5 1/4 divided by 2, because I counted total lines, not just the, so each line pair, 5 point, so that's what, 2.6 or something. 2.6 times 3.3 milliseconds is, let's see, that's going to be 7.5 or so. 3 and 6, 7.8. Carry the 1, 7. Yeah, so it's going to be about 8.5. Great. That's it. Okay, so I'm just going to walk through the Arduino code real quick. Super simple. We're using this library. It's a Timer 1 library. You can find it in the Arduino, the library manager. Just search for Timer 1. You'll find it. Pull it in. It's just an easy way to make this simpler and set it up. Basically, it takes the Timer 1 and gives you an accurate time. So I define this frequency. I want to run at 300 hertz. That's about right. I think I saw that at Cinema 5D. That's what they were using, so best to stay consistent if I want it to work the similar way theirs does. Then you just do the setup. We're using pin 8 for the output. We're using the Timer 1 initialize. This is it's like what, a million microseconds, so 1 second divided by the frequency divided by 2, because we want it to be on for half the scan time and off for half the scan time. That gives us a true 300 hertz square wave in this case, because we're doing 1 second divided by 300 hertz and we're on for half the period. So then we set our Timer 1 to a 50% duty cycle. That's it. So Timer 1, we attach it to an interrupt, and then basically all we do is every time that timer expires, we do a digital write, and we toggle this pin 8. So we write pin 8 with a digital read of the opposite of pin 8. That's all there is really to it. So it's a pretty simple program. You can just copy this code into your own Arduino program and dump it in there. You'll get the same thing I had. Alright, so I'm going to talk some about the results. We did the 4K right there on the bench. I did this, and I've been testing almost all my cameras that I have around just to see what they look like, right? But the 4K is pretty good, right? It comes in right around 15.8 milliseconds of rolling shutter. That's my estimate, so you saw me do the math on that one. At 1080p or with the lower scan rates, it was really consistent too. It was right around 7.5, maybe 8 seconds, somewhere in there, depending on the test. And it didn't seem to matter if it was recording B-RAW or ProRes or any of the different modes that you can set it up. It was pretty much just in sensor scan. If it's the full sensor, it's around 16 milliseconds, and if it's the 2.6K portion of the sensor, then it's 7 or 8 milliseconds, which is quite good. Really, anything under 15 milliseconds or right around 15 and under is pretty usable for me. Although if you're doing a lot of sword play or like filming propellers or helicopters or something with lots of rotary motion in it, it might be a little worse. So I tested my GH5. It's a few years old now. I don't know if it's got the latest firmware, but it did good. I like to shoot in Cinema 4K or Full HD or regular 4K for the most part, usually 24 or 30 frames per second. So the GH5 did really well. It's got a pretty good reputation for rolling shutter, and it shows, right? So it's between 12.5 on the Cinema 4K. I think that's because it's just not quite as tall, in terms of the pixels. So it's got a little less to read out for that. And the others were around 13 to 13.5 milliseconds of rolling shutter. Very, very usable. Still love my GH5. It's a fantastic camera. That's what I shot this video on, although I didn't put a lot of effort into the visuals on this. Just wanted to get the information out there. And now we come to the Z-Cam. This is the whole reason I even bothered to try to build this test rig, because I was getting some really weird behavior out of my Z-Cam rig when I was testing, right? So it's got a bunch of different modes. Z-Cam's a Chinese camera maker. Pretty good build quality, but it's a little quirky. It's got weird stuff that happens. So I did a whole bunch of testing on this. That's exactly why I built it. What was happening for me is on the 4K low noise setting, I was using both Cinema 4K and I was using regular UHD 4K. And the Cinema 4K was, yeah, it's okay. And then you go to UHD 4K and it was just like rolling shutter out the wazoo. I thought my camera was broken. So, and you see that at the very bottom of the chart, there's number 27 and 28, the worst two. It's 30 milliseconds of rolling shutter, and that becomes very noticeable. The other interesting thing on this is the Super 16 modes are quite fast rolling shutter. So if I need something where a little less rolling shutter would be useful, maybe I can switch to that. I haven't made much use of that. But the regular 4K and the Cinema 4K 24p, they're sitting 10, 12 milliseconds, right in that range, depending which specific mode you're in. The wide dynamic range modes obviously add a little bit more rolling shutter, but not as bad as I thought it would be. I thought the wide dynamic range, it might do something silly with the scan times and make it worse. The only one that really did hurt the scan time significantly was the low noise mode for UHD, and the Cinema 4K was not too great either on that at 17 milliseconds. Totally usable, not awful. Actually better than I was expecting. And here's the Zcam E2. I own both the E2 and the E2 M4. They make a great matched pair, although I really don't see the reason to spend 500 extra bucks on the E2 at this point. It does come with a low jello mode, which the E2 M4 doesn't appear to have, at least not in the current firmware, 0.96 I think it is. So the low jello mode knocks it down all the way to like 7.5 milliseconds of rolling shutter, which is about as fast as anything, right? It's even as fast as the Super 16 modes, or a little bit faster. So that's pretty interesting. You notice more noise when you're using that, and you notice that it's just a little bit grainier, and I guess that's what you'd expect, but it does a really good job of, if you need low rolling shutter, it's probably one of the fastest I've seen besides my Ursa Mini 4K, which is a true global shutter. But that comes with other problems, right? It's a huge camera, difficult to carry around. Great image quality, but yeah, it's getting pretty old now. Doesn't even shoot B-RAW. Well, I hope you guys enjoyed it. Thanks for watching.